Then let's start. So I'd like to welcome you all back to this second science seminar series of Agriforwards CDT project. So my name is Fumiya Ida from Cambridge. I'm a deputy director of the center. And I would like to introduce our two lecturers today, Professor Jabbour and Professor Simon Pearson. So we have been working on this CDT project almost 2 years. When I met Simon first time, he came to me enthusiastically about this is the right time to do this agriculture robotics, and we should really set up together a CDT. That time is still a proposal phase, but we actually have a very formed successful team to get this through funded. Lots of things we planned that time is becoming a real thing now. So I'm very, very happy to have Simon to talk about his vision vision and enthusiasm about this field, about for the future, and I'd like him to encourage all of us, including students, how we should view the future through the CDT project with a lot of industry partners and stakeholders. So without further ado, I think I'm going to just give floor to Jabbour and Simon for the lecture today. And we're going to have a lot of discussion time after the lectures, and I'm very much looking forward to your lectures. So yeah, who want to start with?
Jabbour.
Oh, it's me. Yeah.
Okay, Jabbour, please go ahead.
Yeah, so I just share my presentation.
Oh, sorry, I should stop my presentation.
Is it okay?
Yes, we can see you very, very, very well. Go ahead.
Oh, thank you very much for the opportunity of being here with you, learning from this very successful CDT program. And I will be discussing with you sustainable supply chains, smart technologies, and the COVID-19 pandemic, so some research opportunities and challenges. But of course, from a management perspective, because I'm based in a business school, Lincoln International Business School. So the discussion is based on two central objectives. So the first one is to address key issues in green and sustainable supply chains. I believe that most of the technologies that the CDT is going to develop will be deployed and transform supply chains. And the potential research agenda on sustainable supply chains 4.0 after COVID. So as our audience is diverse, I'll just show you the basic concept of supply chain. So a supply chain usually has a focal company, a company which is, the most important company, has the bargaining power in a supply chain. And the supply chain coordinates the movement of goods and data from suppliers to final customers. A supply chain can be either domestic or global modern supply chains. Basically, most of supply chains that we have nowadays are modern and global international supply chains. But 2 decades ago, the need for greener supply chains emerged. based on classic papers like this, when the greening of operations management was defended. And as you can see here, greening the supply chain is one of the pillars of any green and sustainable operations strategy. And then this area called the green supply chain started evolving. You can see here classic papers defining and conceptualizing the meaning of green supply chains. And more recently, colleagues and I have proposed a multi-dimensional framework to understand green supply chain practices. So in this framework, for example, colleagues and I have addressed how organizational theories are useful to understand green supply chain practices such as eco-design, environmental innovations, or green purchasing, or cooperation with customers in a supply chain. So these are green supply chain practices that I believe will be transformed and affected by the technologies that programs like the CDT are developing. But there is another evolution from green to sustainable supply chains. So nowadays, we discuss sustainable supply chains based on this kind of literature, if you are interested in this. And a sustainable supply chain is, of course, the management of material, information, capital flows, cooperation with companies along a supply chain, but taking into account economic, social, and environmental aspects, and also how a supply chain considers the perspectives from customers and stakeholders. So if your supply chain doesn't engage with stakeholders, you can't say you are running a sustainable supply chain. And this is a classic framework in which we can understand the triggers of a supply chain, which is sustainable. So a supply chain to be sustainable must have the focal company investing a lot in sustainability. So if the focal company is not willing to invest in new sustainable technologies practices, any initiative of sustainability in the supply chain will be likely to fail. And you have triggers of a sustainable supply chain. We are talking about government initiatives, customers' pressure, and stakeholders' pressures. So this is a classic framework to understand how sustainable supply chains practices are adopted in complex and modern supply chains. But the question is that COVID-19 is disrupting both green and sustainable supply chains, and much more research about it is necessary. For example, how technologies will reduce, mitigate this disruption. So this is a very interesting graphic, World Uncertainty Index. And as you can see here, we have the privilege of, living the peak of uncertainty in the world. And this uncertainty caused by COVID is really disrupting global supply chains, international supply chains. Why? Because global supply chains rely on international trade and logistics, lean inventories, multi-tiered supply chains. So you have suppliers of suppliers of suppliers, which is very difficult to coordinate. these supply chains are designed to keep inventory and the labor cost at minimum, access to key suppliers and markets. These global supply chains might suffer from cost-cut obsession, and they might suffer from systemic weaknesses. So what happens with global supply chains is that they have reduced internal risks related to inventory and reduce the number of suppliers. But as supply chains go global, they increase very much external risks of disruption. And as you can see here, COVID-19 has created 3 kinds of risks and disruptions. For example, sustainable supply chains during the pandemic found themselves in a difficult situation concerning business goals. So lack of productivity, profitability, revenue, shareholder obligations, and the customers' complaints went up. Social and environmental disruptions. So the safety and the well-being of the workforce was affected. Generation of jobs, payment of tax, fair treatment of suppliers, capacity to run waste management, recycling initiatives. And the customer satisfaction was also affected. For example, availability of products and services, quality of products, health and safety, fair prices. So as you can see here, COVID-19 is disrupting many of these dimensions of sustainable supply chains. And there has been evidence that smart technologies will enhance the sustainability of supply chains by mitigating those potential disruptions. So, for example, if you look at the Financial Times, it has been reported that COVID-19 is really accelerating the adoption of Industry 4.0 technologies. Wall Street Journal has just said that COVID-19 is triggering major adoption of Industry 4.0 technologies in supply chains. Most technologies relate to remote working, contactless technologies in supply chains, and automation. So robots, and so these are trends that are here to stay, probably. This report says that supply chains in the future will be supply chains 4.0, intense on Internet of Things, advanced robotics, blockchain, big data, predictive analytics. And these technologies will unlock faster, more accurate, more flexible, efficient, automated, and we hope as well, greener supply chains, reducing waste. But there are many questions to be investigated further. For example, will smart technologies unlock truly sustainable supply chains? And this is because those frameworks about the meaning of sustainable supply chains are relevant. Otherwise, we can't understand the impact of smart technologies on supply chains. What are the critical factors of the integration of green and sustainable chains and the Industry 4.0 technologies? What companies should do? What managers must know about integrating and adopting smart technologies? We are talking about motivators, drivers, and organizational barriers. Will emerging technologies such as blockchain enhance transparency of sustainable supply chains? We can talk about modern slavery in supply chains and how blockchain will be important to deal with this. How Industry 4.0 technologies can enhance multi-tier supply chains when you have suppliers of suppliers of suppliers in different locations in the world. The challenges of sustainable supply chains 4.0 in emerging markets, when you have institutional characteristics that should be observed. How to manage cutting-edge innovation across members of a supply chain. For example, the CDT develops a new technology, how to ensure that this technology will be adopted by members in a supply chain. But the great question is also how to ensure that new smart technologies in sustainable chains are socially responsible. So this is a big question. And if you have a look at this recent report that after COVID, the consumers and companies will be more interested in sustainability, corporate social responsibility, local producers, local, for example, buying local. So the question is how to ensure that digital technologies, smart new technologies are responsible. And I bring to the debate this recent framework published in MIT Sloan Management Review. With a framework, it's still a theoretical framework. It's still to be applied. But it's very interesting because the question here is how to ensure that Industry 4.0 new technologies are socially responsible. For example, you can ensure that there is data privacy. Data is protected for all employees, customers, and the other stakeholders. What about diversity and inclusion? Will the new technology ensure these dimensions? Regarding the economic dimension, will the new technology replace jobs done by humans? Will this be responsible? How to mitigate the effects? In terms of environmental impacts, how to ensure that the development of the technology itself is environmentally responsible and that the technology will reduce waste and environmental impact in the long run. And from the technological side, how to ensure that artificial intelligence is applied in an ethical way. For example, what about cybersecurity? So this is a very interesting debate that, of course, sustainable supply chains will be much more intense in terms of adoption of Industry 4.0 technologies. But as consumers and companies will pay more attention to sustainability, how to ensure that new technologies are responsible. So I hope this will add to the debate. There are useful references here. And I thank you very much for the opportunity of being here, the CDT team, Professor Simon and Professor Ida. Thank you very much.
Okay, thank you very much, Jabbour. I think this was really, really interesting discussion.
Yeah, I just need to.
Mia, you're on mute at the moment.
Okay, thank you very much for the very nice, inspiring presentation, Jabbour. I think we can continue this discussion after the Simon's talk. So, well, before going to Simon's talk, I just want to remind everyone, if you have any questions or comments or suggestions for discussion topics, please write in the chat box so that we can pick up your comments. Okay, so yeah, then I give the floor to Simon. Do you want to go ahead?
Yep. Okay. Can you hear me? Is that okay? Yep.
Yes.
Okay. I'm going to share my screen. Okay. All right. Well, thanks very much, Famir, and thanks, Jabbour. I really like that last slide, Jabbour, the corporate digital responsibility, and it's a really excellent framework. And one of the things that with Agri Robotics we really need to think about, that sort of social aspect of agricultural robotics as we go headlong into the adoption of these technologies. It's quite crucial that we really think that through quite clearly. So I think that's a great feed into what I'm going to talk about. Really, my talk though is I guess what I wanted to do this afternoon is really highlight some of the work that we've been doing across the UK with the agri-robotic community and the produce community, really as a consequence of COVID and the extraordinary impact that's had on farm labour supply. I guess we knew with issues associated with Brexit that there was a big drive towards agri-robotics because of this potential impact on access to labour for the industry in the future post Brexit, and that's still very much a big concern for the sector. But what COVID's done is just dramatically accelerated the impact of that in a way which nobody anticipated, in a way which is far worse than I think anybody anticipated for Brexit. So it's been a very good, not a good lesson, but it's been a very effective lesson for the industry on how to respond to some of these threats. So what I want to show today is really go through some of the work we've been doing, but also really articulate the case again for agri-robotics and contextualize it a little bit around COVID, and then some of the opportunities that might give for future research. So let's. So just to go back to the start, I just want to really reintroduce Tom Duckett's white paper, which was quite crucial in founding the CDT. And if you've not read this, then please have a look at it. It still stands. Tom produced this with a collaboration of many people across the UK, particularly in the robotics community, looking at where agri-robotics can have a crucial impact. And we think this was a foundation stone for what we've been doing in the CDT. And really, agri-robotics, what is it? Well, it's robotic technology. So that's the bottom half of this diagram. And I think as we've gone on, we've really shown what a wonderful, rich area Agri provides for the robotic community for research. It really, there is tremendous amount of opportunity to really develop some innovative robotic solutions for this sector, whether that's in autonomy, so very complex issues of how you move autonomous vehicles in GPS rich or GPS denied environments, in complex spaces with humans in the loop. Very challenging robotic research required. Manipulation and grasping, which is what Famir specializes in. But how do you pick a strawberry without damaging a strawberry? It's incredibly soft. It's really very challenging. How do you recognize it? The image processing. How do you size it? How do you provide decision supports to the farm? And then the other really exciting area that I think we're getting is how do you operate those robots as a fleet, so a proper fleet. This is beyond, you know, I look at what some of these industrial warehouses done, Amazon and all those people, but that's fleet in a relatively structured environment, but fleet robotics in a completely unstructured environment is really quite challenging. So I think it's a beautifully rich area for research. And then as we go forward with new telecoms, there's 5G opportunities and all sorts of data-rich research. What we're interested in the agri domain, which is really my area, is really an opportunity to step change agriculture with robotics. And again, as we've gone on through the CDT and over the last 2 to 3 years, we've really started to understand where the opportunity arises in these technologies. And the key one I want to mention today is around selective harvesting. So there's huge opportunities around selective harvesting. I think we've been asked to harvest pretty much every fruit and veg that people eat, that whether it's mushrooms, tomatoes, strawberries, raspberries, there's opportunities in that space. But the really exciting areas, the other exciting areas are crop care, so robots wandering around the environment, doing things which reduce the use of pesticides to protect the environment, reduce the use of fertilizers, to optimize crop yield, to reduce carbon use. There's a whole layer of technologies there. And then the next thing that we're all interested in is phenotyping. So that's using robotics to identify traits and new varieties so that farmers can increase yield in a sustainably intensive way without increasing the amount of input. So new genetic traits as well. So it really is a rich area for research. But what I want to do here is really reflect on some of the opportunities, particularly that's come up around COVID. And I've used a Donald Rumsfeld run-in on this. And I just wanted to show everybody what the state is. Just to give you a good example, this is a picture, a 1980s picture of fruit picking, which you can see it's very manual. The robot there is a pushcart trolley, automated by one-person power, and that's pretty much where a lot of the fruit picking is at the moment. So to give you an idea of the numbers, there's 30,000 fruit pickers today picking strawberries across the UK. So 30,000 people doing that job. Within the seasonal migrant labour pool, there's about 69,000 in total. So about half of the people are in the fruit sector. What is it like today? Well, it hasn't really changed in 40 years. So there's no really that's where it's at, and the need now to change is really very urgent, and it's driven by access to labour, but also increasing cost. And we've all become very familiar with what are relatively low price foods in the UK. And if you look at food pricing internationally, we do have relatively low cost foods. Now, in crops such as soft fruit, a very large proportion of the cost of that food is labour. What we're seeing at the moment is labour costs going up, and that's driven by national living wage, but also as labour productivity is also decreasing, labour costs are going up. So we're hearing lots of inflationary pressures on food prices as well, which are coming through. So it's not just about labour, it's about cost of food, and that comes through to the consumer as well. That's in soft fruit, and I'll just give you one quick one on field veg, and that is the state of the art on field veg harvesting, and which is an area which Vermeer does research in. But this is where it's at, and so it's a very simple tractor, and there's just lots and lots of people stooped over cutting crops in fields, and if that's a Lincolnshire field where I live, that's going to be a fairly cold field. So, and particularly when it's raining, it's horrible. It's not an easy job. I really hate the press or the people when they say this is a low skilled job. That is actually a high skilled job. It needs a very high level of intrinsic fitness, and unfortunately, though, it's a low paid job. So the notion of skills and pay get conflated, but that's a skilled job which is low paid. So, but it's not particularly pleasant job either. So, the known unknowns. Well, we've talked about Brexit, but COVID's been absolutely transformational in terms of the impact of COVID, because of the access to labour issues. When the lockdown happened, a lot of the pickers weren't in the country, and so there was a real concern about access to labour for this harvest. And then there's been all sorts of stuff going on with the DEFRA's and the industry's Pick for Britain campaign to try and get furloughed workers into the sector, students and whatnot. And there's been, you know, it's not been unsuccessful. It's not given the numbers that everybody wanted. But what's happened in the industry is there's a large pool of unskilled workers who have come into the sector. Average labour prices have gone up, so cost of picking has gone up. So that creates a food security issue. And then of course, as COVID's gone on, Brexit's still going on, and that's going to go on through January, and that will impact in future years. So, and just to highlight some of the press, so COVID is transformational, and these are just some of the things I've just picked up. So, all the press has been on it. So here's the Guardian: fruit and veg will run out unless Britain charters planes flying farm workers from Eastern Europe, and that hit the press in April. And yeah, the farms did. They chartered a lot of jets, so a lot of jets were chartered, and actually a big proportion of the labour that's been involved in the industry today are people who've flown in on chartered flights. So they've had a big impact. It's been a positive step. And then you also look at other areas. So this one in the Sun, daily spread. Leicester outbreak started in food factories. So Leicester's under lockdown, and it's well reported that there's a lot of COVID transmission in food factories. So that remains a risk. This thing seems to thrive at around 4 degrees C, but in food factories, they're very closed environments, so very difficult to contain that risk in those factories. So Leicester, part of the reason, it's not a full reason, it's been locked down. Daily Mail. And then you've got the events in Hereford, poor vegetable farmers, where 73, 75 workers caught COVID on the farm. Absolutely disastrous for those people who've been involved in that, and very, very worrying for the industry that sort of thing's happening. And then the Daily Star, I've really got to mention this one. So farmers trial robots, coronavirus cut supply of seasonal workers. I was quoted in the Daily Star, so I was quite chuffed about that. And I haven't got any 4-star papers or 3-star papers, but I've got a Daily Star paper, so I was quite pleased about that one. So, but you can see the everybody knows it, so I don't have to repeat it. So what I've been doing, so what we tried to do, and it was really as a function of the CDT Steering Board meeting in March, and it was just after lockdown when we had the CDT Steering Board meeting. And this has sprung out of the CDT. No equivocation. This is a direct impact of the CDT, and that came at the Steering Board. The Steering Board includes a number of people from industry, including Ali Kappa from the NFU, who's head of horticulture, Jeremy Haddle from the MTC, Dave Ross from Agri-Epi. So we've got some very good people on the Steering Board of the CDT. And it was just as lockdown came, we thought, well, one of the solutions to this, it must be robotics. So how do we coalesce the community around the notion of trying to accelerate robotics as part of the COVID response? And what we've been able to do was I think we ran 6 webinars. We've had about 50% of the produce industry in the UK by volume of turnover involved at the supply side. And then a whole raft of Agri Robotics companies, SMEs, large companies, and then a whole raft of companies who are in the supply chain who might help with scaling that technology. So tremendous goodwill that's been generated through the process. And so in terms of a call to get the industry together, it's been fantastically useful. The KTN for us, part of Innovate UK, ran the webinars, and the EPSRC, the colleagues who sponsored the CDT, were very influential in trying to bring together UKRI support for what we've been doing. So that's been, very grateful for all the support that they've given us. And we went out to the industry and we said, are these concerns, this is the produce industry, are these concerns real? We did a number of polling questions, and this was the feedback. So we asked the question, how will labour shortage or change in supply impact your business? So they're saying automations need to increase, there'll be shortages, labour's going to be in short supply, they need tech solutions, they want to accelerate investment in robotics, they want to rethink crops for next year. Some of them saying if they can't have confidence they've got labour post January 2021, they might not even plant any crops because there's a risk they won't be able to harvest them. They need accessibility of skilled engineers and all these sorts of things. So, but palpable concerns about access to labour, and those concerns haven't gone away. I think they've got labour, but the cost of labour has gone up through this this season. Then we asked the robotic community to achieve accelerated development, what would you need? So, and there were 5 key points that came out of that, and there's a word cloud which shows all of the feedback we got from the robotics community. One was funding to scale, and at the time the ventilator challenge had just launched, and what we really wanted to do was something similar to the ventilator challenge but for robotics, to go this year to high level proof of concept to scalable technologies for next year. So funding for that was really key, not just to finish the technologies but also to purchase equipment for scaling. So that was really key. So funding was really important, and we've asked UKRI for £12 million to help scaling. We're still waiting on a response for that. It seems to be taking quite a while, but we still have the ask in UKRI for that funding, and we've got to at least 2 ministers. So we're just waiting for a response to that. It's getting the clock's ticking now, but we've managed to do that. The other thing was engineers. So for all the students in this, there's a real need. There's a real gap of engineers, and that's engineers at all levels. That's robotics, computer science, hardware, software engineers. A real need, a shortage of engineers in this sector. There's a call for evaluation sites. We think we've got that solved, and there are a number of farmers who are now offering their sites and facilities for research. So if anybody needs sites, let me know and I can see if I can match you up. What it's really done was collaboration, and we've been overwhelmed with the feedback we've had about collaboration. And for the first time, we got people coming in who are building motors. So we're talking to companies who do e-hub motors for agricultural vehicles for the first time. We're talking to people with very advanced software, with industrial autonomous systems who want to get into the agri domain. So we've been absolutely overwhelmed. We've been talking to very big automotive manufacturers who've got some of their engineering staff on furlough who want to try and get them into agri. So collaboration has been fantastic, and there's lots of tremendous goodwill out there for this. And then the other area was scaling. So who's going to make these robots to get them into commercial things at high speed, which is the other area we've done. It's not just on the manufacturing, but it's on things like the safety testing, CE testing, and all that sort of stuff where we've had a lot of support. Within industry, someone solved these problems out there for some reason, but for another reason, but we've got a good opportunity for people to apply those skills here. So that's been tremendous. And then it's hit the press as well. This is a Dogtooth Robot in the Financial Times. And here you go, coronavirus accelerates the rise of the robot harvester. And it's very true. We've seen interest in this all around the world. We've been talking to teams in the US who've got the same problem, teams in Israel, Holland, Norway, who are all trying to accelerate the development of these robotic technologies. And that robot there, that's a Dogtooth Robot, and that's they're based just outside Cambridge, so, and part of the CDT. So they've been very active in the process. So that's really what we wanted to do, and that's where we've got. And in terms of the consortium, we ended up in the process. Really, we've identified 5 key consortia who we think were close to getting robots over the line for next year if we'd started this year. And I think because of the delays on funding, we might not make that next year unless something happens very quickly. And what it showed to me was the 5 key consortia. 2 are on strawberries, strawberry harvesting, one by Saga Robotics, who operate out of Lincoln, one by Dogtooth, operating out of Cambridge. There's a 3rd one on blueberries, operated by Berry Gardens, who are based in Kent, who work with us at Lincoln, very close collaboration. There's a veg harvesting consortium based in the north of south of the Humber, and then there's also an apple picking consortium that's come together as a result of this process. So what we've been able to show is that the UK has got a very rich talent pool of robotic companies who are active in this area. And I thought that was brilliant. I think it's just to really understand where the UK is in this domain was really encouraging, and we are in a good position. We've got a lot of very good capability in the country, and a lot of those are related to the CDT. They've all got research needs, and I think the CDT particularly can help some of these companies. So that's robotic acceleration. That's where we got. As I say, we're still waiting to hear whether we've got any additional funding. I'm kind of thinking probably not at the moment, because we would have heard. But what we've done through the CDT is create a tremendous amount of goodwill, and also a real focus for all those companies out there who want to succeed, and a real focus for all the research that's going on to resolve some of those key challenges that the industry is facing. So if anybody wants any more detail on that, please get in touch, and we can help make contacts for you. And then really it's just a couple of last slides. I just wanted to show people, I mean, a lot of people might have seen this already, sort of where the state of the art is on some of the technologies that we develop. And this is a short 2-3 minute video just showing where we're at with strawberry robotics. And this is a collaboration between lots and lots of people at Lincoln, with Tom, Mark Hanhide, Greg Chilianak. There's just many people to mention. Berry Gardens growers, who are our industrial sponsor, and Saga Robotics. And what this video shows you is the sort of scope and the opportunity within Agri Robotics. So if anyone is is relatively new to the field, I just wanted to give a real flavour of what's going on and some of the exciting stuff that's happening. And at the end of this video, that you'll see a video of a guy called Raymond Kirk, who's a BBSRC student. So he was in a cohort before the CDT started, but he's at the end. And just to show you sort of some of the things that's doing. So he was on TV quite recently on Countryfile, showing his work where we challenge Countryfile presenters against our robots. And that was done by one of our PhD students. And I think it's quite a cool bit of work, and it just shows the place where we can go if we get some of these projects right. So this is the sort of thing that's happening with Saga Robotics at Lincoln. This is the 4-valve robot. Most of you will have seen. It's a very effective robot, about 150 kilograms, 4 500-watt DC motors. We have a large number of these now at Lincoln. I think there's a Saga pool and a Lincoln pool. There's probably 10 of them around now. I don't quite know the exact number. And they're operating. We're starting to work in sort of fleet operations. So Mark Hanhide's very active in that in terms of the autonomy stack, and that's working with some of the work that Tom's been doing over many years. And lots of PhD opportunities around autonomy. This just shows the system, one of the systems operating. This is in Norway. So you've got Robot World on the top, and then the robot at the bottom. So that's effectively very well. So again, anybody wants research on autonomy, it's great. Then we've shown some really new applications. This is a Norwegian application by Saga of putting UVC robotics into some greenhouse crops. UVC stops powdery mildew, reduces the use of fungicides. And then as we speak now, Saga have got 3 robots in Kent on commercial trial doing this every night, a completely autonomous operation of UVC to reduce powdery mildew. And the robots every night, I think, are now doing about 8.5 kilometers of autonomy every night. And that's been happening since barge. So fantastic. It really is working very well. We are working on a logistics support, which is a UGV to move fruit around nurseries. There's Greg in the background if you saw him. And this was field tested last year in Kent in a company called Clockhouse Farm with Berry Gardens, our main sponsor. And this just shows the degree of the autonomy, which I think is just incredibly fantastic level of autonomy. So you've got fruit pickers moving across the top of the tunnel there. They're picking normally on a trolley. They're going to use the robot as a UGV. I'm going to call it about now. Robot's coming, here you go. And then fruit then gets whizzed away to a picking station. So that's coming. So high degree of autonomy, lots of research there in that area. UEL, we've got a robot fruit farm, which has been crucial to what we've done. That's been funded by Berry Gardens. It's absolutely where it's at. And we started picking, and we actually picked our first fruit with a robot at Lincoln on our fruit. I think it was about 10 days ago. So absolute fantastic breakthrough moment for us using this system. So we are making quite a good progress. And then this is some of the work from one of our PhD students, Raymond Kirk, which is image analysis. So it's fruit recognition, but he's also sizing the fruit, looking at maturity, doing 3D reconstruction of the fruit so we can size them. And that's now going on to a new project for using machine learning for crop forecasting. So that's crucial for farmers, that they know how much fruit they've got, and accurate forecasting is key. And this is a foundational project for forecasting. That's done by Raymond Kirk, and plus a load of other PhD students working with Raymond, I should say. So it's quite a large team effort. And this is localization, so he can go back and detect individual fruits on different runs of the robot. And the next section will just show Raymond
the first one
on TV.
Counting. What we're going to try and get you to do is count faster and more accurately than it can.
So how does it count the strawberries? What is it looking for?
Yeah, so we use vision. It's going to use this camera right there, looking at the row, and it's going to detect the position of the ripe and unripe strawberries.
This space tech strawberry counting race is on. It's time for me to pit my wits against this robotic rival. 3, 2, 1, blast off. The fruit count is on, and I'm giving it everything I've got.
Okay, so that was Raymond on TV. He's much more photogenic than I am. He seems to have got lots of offers on the back of that, but Raymond's at the end of his PhD, and I just thought for all the students on this webinar, the amazing things that you can achieve in a short period in a PhD, and I think Raymond is a great example of what can be achieved in a single PhD. So we're very proud of what he's done. So so that's really the sort of flavour. There's incredibly rich area for research. We talked about the accelerated automation program, but it's not just about selective harvesting. And this last one, this is an image which sent to me by Paul From, who's the CEO of Saga, which just shows how unsustainable agriculture is. And this just really is, I thought it's a great video because it just shows there's so much more to do. And can we go on with agricultural practices as they are, with the amount of pesticides that are used, heavyweight vehicles impacting the environment. Robotics are transformational because it can solve many of these problems. So why can't we have a fleet of smaller robots? They might not be, they're going to be bigger than the 4-valve robot, but they're going to be intermediary. Why can't we have robots that reduce the use of pesticides and all those things that damage the environment, and so on and so on. So I think we're just at the start of agricultural robotics, and I think this CDT is going to be one of those foundational bits of work which really moves the field on. So we're at the beginning, so we just have to keep going. We need to completely rethink the way that we do agriculture. So thank you. That's it from me. All right.
Okay, thank you very much, Simon. It's a wonderful introduction. So I think we have time for some discussion and questions, and we've got some questions in the chat window. If you can look at them, I think we can start from there. So the first question to Simon is, we observe many times that the products have been gradually adopted to supermarket needs, such as chemicals help to produce food, increase its shelf life, and so on. But with the introduction of robotics, will be bring similar changes to foods, such as like strawberries will become as more crunchy as apples.
Well, we've not really thought about that one, but the really I think the really exciting thing is phenotyping for crop selection, and again that's next up really. And so you will have a situation, I'm absolutely sure, where you'll have robots selecting varieties which are ideally harvested by robots. So I think that's going to be transformational in terms of the way that farmers grow, but also in phenotype. We are going to see lots of new traits, and you know, I look at wheat breeding. You know, many wheat breeders will have 2,000 or 3,000 plots, and it's done with a person with a clipboard. Looking for very small differences. You can't identify change with a clipboard. Robots are going to again be transformational in the way that we do plant breeding. So we're going to see a whole new range of genetics coming through, I'm sure.
Right. Yeah. So we can do both robotics innovation and the crop innovation at the same time, I suppose.
Yeah.
Okay. The next question to Jabbour. What do you think will change in management of supply chain with the introduction of robotics technologies? Do you have any comments on this question?
This is a very interesting question, because from a sustainable supply chain point of view, of course, we believe supply chains will be faster, more reliable, and you know, greener. But of course, we need to assess all the dimensions and the impacts of robots in sustainability of supply chains. So new questions emerge. What about, you know, training, jobs generation, or environmental impacts? For example, CDT's technologies can clearly reduce waste, and this is amazing. But how to make a business case, to build up a business case, and, you know, show up these achievements? So there are different lines of research from a sustainability point of view, and new issues will emerge, such as ethics, cybersecurity, and all new questions that you are just open the doors to new questions because you are generating innovative technologies.
Do you actually expect more investment will be necessary to technologies because of introduction of more and more automated solutions?
Yeah, it's always about the time horizon that you consider, because, you know, investing on robots, it can be expensive now, but in the long run, you will save money, and you will be able to provide food, you know, to more people, lower cost, and this is also sustainable. So it's, you know, a multi-dimensional problem that you need to understand from different angles. It's a very good, you know, question.
Okay, thank you very much. We got another question, I guess, to both of you. Why does the supply chain have such varying levels of innovation? Or rather, which parts of the supply chain are more innovative and why? This is a very interesting question.
Yeah, my world is the fresh produce supply chain, which you know, I've spent many years in. One, the innovation is around the buyer power. There's asymmetric power within the supply chain, with retailers having extraordinary power. That puts cost pressure on the producers, so they have to keep innovating to survive. So it's a very, very, very competitive market, and that creates an innovative space. The other reason they're quite innovative is that they have to cope with extraordinary volatility. So you've got a short shelf life product, orders which are uncertain because it's just replenishment orders from consumer buying. You don't quite know how many people are going to buy your produce, and you need to really be innovative to cope with that volatility on a day-to-day basis. So it's a fairly tough, challenging, competitive environment. I think that creates some degree of innovation.
Okay, Jabbour,
yeah, you know, a supply chain, how innovative is a supply chain depends on how innovative is the focal company in that supply chain. So is the company the central company in the supply chain? Is the company which has, you know, the bargaining power and the power to, you know, establish collaboration with other partners, with universities? So if you have a very innovative focal company, so probably your supply chain as a whole, it will be quite innovative. But we also talk about the 3 T's. So we are talking about trust. So, you know, trust among partners in a supply chain, transparency. So the way they share innovation, and time. So when a partner in a supply chain is aware of, you know, the time, how much time a supplier needs to implement a technology or a university to develop a technology. So time is crucial. So when people are aware of the time required for a task or a project, they, you know, it builds transparency. And yeah, so we talk about the 3 T's. So it's time, trust, and transparency, which leads to innovation as well.
Okay, yeah, thank you very much. I think the supply chain challenge complexity is probably one of the biggest and most significant barriers for our technologies to be deployed in this sector. So I think this discussion should continue throughout the next years of a CDT project. And I think this is going to be a very, very important and interesting discussion we should continue in the future. So I think for the sake of time, I would like to stop this seminar at this point. And I'm pretty sure Jabbour and Simon are available for any further questions by emails or in whatever channels that you have. So thank you very much once again for this wonderful, inspiring talks today. And we will have the next science seminar in September. We're going to skip August, the holiday time, but we are expecting on the day of 18th of September at the same time with another lecture on that day. So until then, we'll see you again in the science seminar series in September. Otherwise, I wish you all a good summer holidays. And thank you very much for attending this session. Thank you very much. Bye-bye.
Thank you. Bye.
Thank you.